inviting me here today. I'm excited to be back in Ukraine, and I'm glad that SoftServe invited me to speak to you today. Today I'm going to talk a little bit about the future of data management. In this talk, I'll start off by discussing the big data phenomenon and why it is a reality today. I'll also talk a little bit about the technology that supports big data. And finally, I'll go through a few customer use cases to help you understand how this technology is being applied. Before we get started, though, I have a question for all of you. How many of you, if you raise your hand, if you know what this is a picture of? Okay. Well, it sounds like a few of you do. It's a picture of the yellow plush elephant that was the little guy who gave Hadoop his name. This was the stuffed animal of Doug Cutting's son, and he had named it Hadoop, which is the origin of the name of the platform in which we're going to be discussing today. Just a little background on the company that I work for, Cloudera. If you haven't heard of us, we provide infrastructure for big data, and we help organizations leverage their data to really ask bigger questions and drive their business, and hopefully increase their revenues and increase the breadth and depth of their business by focusing on things that they haven't been able to ask in the past. We're amongst a revolution, a data revolution today, and it's at the very beginnings of it. Google and Facebook really helped start this by inventing this technology, and Yahoo. However, more and more companies are starting to join this revolution. And the reason why it's a revolution is you can make very direct comparisons to the Industrial Revolution of the 17th and 18th century. So in the 17th and 18th century, you saw manufacturing processes and products become more efficient and cheaper. And as a result, the consumers like you and I, back in those times, got products that had higher level service, higher value to them, but at a cheaper price. And we saw this happen over and over during those times. And that's also happening today with the data revolution. We see companies like Netflix who are providing us personalized movie recommendations almost at a very, very cheap price. And you see more and more companies like this providing services that are cheaper than they were a few years ago and at higher value to us. So that's why we're at the beginning of a data revolution, and it's exciting times for all of us to see all these products evolve. In a revolution such as this, and such as in the Industrial Revolution, something's having to drive entire industries and not just specific businesses within industries. And so that is happening today. You see the telecommunications industry that's optimizing network performance by analyzing all of the call logs and all of the network traffic, combining that to provide a faster, a more effective, and efficient network for all of us to use. You see the retail industry that's providing advertisements that many of you have probably seen to a point where you might be sick of them, but very targeted marketing where they know things that you're interested in simply by scanning social media or even potentially your email, things like that. But they're able to correlate all this data and provide you very targeted marketing and services. The public sector, the governments across the world are using data to find and track down criminals, sometimes before they even act. They're analyzing patterns from past criminal activity to try to get ahead of that. And they're implementing new techniques that have not been utilized before. The financial service industry is protecting us against money laundering and fraud by analyzing transactions and all of the data that's out there around money moving back and forth between countries, or money and transactions that are happening, deposits, withdrawals, and they're able to recognize patterns to protect us all against money laundering and fraud. You also see big advances in the healthcare industry. It's one of the most exciting industries. As an employee of Cloudera, when I hear the use cases in the healthcare industry, it really gives you kind of a warm and fuzzy feeling. But what's happening is we're really taking all the data that's known about a given individual, their genetic makeup, along with illnesses that we know, and we're studying patterns that we see across the world with these illnesses. We're studying what happens after people are released from the hospital and how often they return back. And all of this allows us to really have personalized medicine and personalized treatment. And the healthcare every day is making huge strides in ways that protect our own health, and also will set us up well for the future. But just like before, I mean, with this new data revolution, data has always driven business. That's not a new thing. But what's happening now is director level or VP level people that are running organizations within companies are able to ask different questions that they asked before. And that's a theme that you'll kind of hear us as we talk about big data, is because it really enables questions to be asked. And then using that data, you find answers that you did not know before. And so, for example, one question a sales VP might ask is, how do I increase the conversion of my leads that I've been buying now for the past 10 or 15 years by just 5%? And one of the answers could possibly be, if you analyze all of the data that we know about each of these leads through scanning the internet, things like LinkedIn and Facebook and Twitter, to find out what these people are interested in, we can reprioritize these leads and convert 5% more, because we're able to spend our time and money on the higher priority leads. And that's an example of how sales is improving their processes, which is ultimately makes the products that we buy cheaper. You also see companies that release products, especially digital products, that they're measuring and tracking every click throughout the click stream from a mobile phone or from the internet. They're scanning all of that data and understanding what makes users adopt their product and what makes users not adopt their product. And so you see, directors of products asking, how do we increase the user adoption by 10%? And the answers are coming from this data that they are gathering. In customer support organizations, you see directors asking, well, how do we, decrease our churn? And churn can be, you have the same question being asked, the same problem being encountered. And what you can do with that is you can really scan and understand all the data from past customer support cases, correlate those for new cases, and if you find some sort of pattern, you can proactively go out to your customers and say, you're about to encounter this problem. And so that reduces the churn. And so it gives support engineers and support directors a way to really reduce this and save money within their organization, ultimately making the product and service that they provide cheaper for the end consumer. So there are some naysayers out there that say, well, big data is just a buzzword. And we've had lots of data for many, many years. Why is big data happening now? What is different about today than, say, in 2002 when data warehousing was the latest buzzword? There are a few things different, and I can give you three main reasons why. The first one is data is fueling this opportunity. And what I mean by that is the web and the mobile clickstream data, these mobile phones that we all have now, is creating exponentially more data than existed in 2002, for example. And we are tracking and saving that data every single day by every single person in the globe that's using it. This is an enormous amount of data. In addition, social media and the introduction and adoption of social media is also creating a lot of data that, when analyzed, a lot can be learned from. Then you add in manufacturers who are now manufacturing smart devices and smart parts that go into their appliances and their machines that have sensors that track diagnostic data every day, all day long. And this data can also be saved away. And then finally, another big source of data is the audio and image and video data that we also can now generate with our smartphones or tiny little cameras that we can carry with us whenever. And the combination of all four of these sources, it's what's fueling this big data phenomenon. And that's one reason why it's a reality today and not just a buzzword. The second reason is there's now access to new technology to analyze this data. So for example, the video and the voice and image data, we have ways to really intelligently extract information out of photographs, for example, or videos that we did not have 5 or 6 years ago, at least readily available to programmers and developers like you all. We also have new search techniques that can search through non-structured data, so above SQL in a sense, and to be able to find things that we couldn't find in data. We also have the ability to do sentiment analysis, and we have technology that helps us build graphs of social trends. And all of this is new technology that allows us to understand these 4 new sources of data that we had before, or we didn't have before. But finally, and I think most important, is people are requiring it. It's now become a status quo for us as consumers to expect this kind of thing, to expect the products we bought to have considered the analysis and understand us as consumers. Before I ever sign up, say, for a new online book reading site, I expect them to know what I already like and to recommend that. It's just become part of daily life. And we just recently took a survey of CEOs across the United States, and we asked them, you know, how important is big data analytics to your company? And 80% of them responded saying it was very, very important, and it was in their top 5 strategic things for this year. So what we're seeing is it's becoming expected and also demanded by consumers. So these 3 things put together is why big data is a reality. If you see from this chart, there's a rather linear chart that shows the amount of data that's been stored by major enterprises across the United States. So what this is depicting is essentially the amount of petabytes or terabytes that are being housed by the Oracles and the SAPs and the NetSuites of the world. And it's rather linear, and the reason why it's linear is because it's limited by cost and resources. And so it really correlates to the growth that those companies have had. And if you average out all the growth from most companies across the United States, you find, you know, a rather linear growth of revenue. And the data that they're storing kind of mirrors that, because they're limited by how much data they can store by the amount of revenue they make and the amount of money they can spend. And the reason why is, you know, these things are very expensive to do. But if you look at what's actually been happening, is you see an exponential amount of growth over the past 5 or 6 years. And these are from the 4 sources of data that I mentioned earlier. And most of this data is unstructured, and it is very difficult to store in an Oracle or an SAP. And it comes from all kinds of different sources, you know, from video cameras to the social media, from PDFs to sensor data that's been captured. And as a result, you know, this is creating a lot of technological challenges. It's also creating security challenges, policy. Government policies are having to reconsider the new world and decide whether they need to alter some of the, you know, the governing policies that, like, for example, you know, how you protect personal information and things like that. So it's really causing a lot of confusion, a lot of disruption in the market today. We did a study, and we determined that it costs today companies who do it in the sense to quote the old way by using an Oracle database server, a data warehouse, and ETL processes, that it costs them about $30,000 per terabyte per year to house that data. And these systems are very hard to scale because you have to buy expensive hardware for one to support it. You also have to buy expensive licensed software. These SAP and Oracle licenses do not come cheap, and it's very special purpose. So you kind of separate the data storage from the actual applications that are using it, and you end up with a problem because, as you saw in the last chart, as data is doubling almost every year, it becomes impossible to save all of your data year after year, because you might be able to afford it this year, but if it doubles next year, you're unlikely to have double the budget next year. And so it is basically impossible for companies to keep up using the old ways of ETL and relational databases. But with Hadoop, and what the new way is it leverages economical and commodity hardware, which makes it much cheaper. We estimate that it's about 1 to 3% cheaper, about $100 to $1,000 per terabyte per year to house data in Hadoop. That's very, very cheap compared to an Oracle server and a NAS or a SON with expensive data storage. In addition, Hadoop is highly scalable, so you're really not limited. You can add more commodity hardware at a cheap price to continue adding more and more data. And because of these two things, the economics of it as well as the scalability, it actually is attainable to dream to save all the data that you get each year, every year. And that is what's behind Hadoop and is what the main driving reason that it's becoming a solution. I'm going to go into a little bit more detail about the legacy way to help you kind of understand the differences. So the first difference is when you have the old way of doing things, many decisions have to be made about what data you are willing to store because it is expensive to store it. So a lot of organizations have to make tough decisions about, say, data older than a certain thing or data not relevant to what the current business problem is of today. And what they end up doing is they take that data and they archive it off to cheaper storage, perhaps a tape drive or some backup system, with the intent that they always have access to it. But the problem is over time, their systems evolve and it becomes practically impossible to go back and get that data if you find that it could be useful to you in the future. And that is what we call dark data. And it's the first real challenge of the legacy way in this new age of big data. Because you end up with having to reduce the data set just simply because you can't afford to keep the data. The second challenge is around the ETL process. So with ETL, you have to do upfront modeling to model out your tables and your objects. And in this process, you have to decide which fields are important to you at that moment before you put the data into your data warehouse. And so once you have done that modeling, it's a time-consuming process to transform the data, but in that process, you actually lose data because you had to decide that maybe a phone number was important but not an address or something like that. And so again, the data set that you're working with is being reduced, and the applications that are leveraging this data no longer have access to that data. The third challenge is really in this ETL process, in the transformation, you have to ask yourself, well, what questions do I want to know about the data first? That's the first thing you have to do. Then you can understand, okay, given I want to learn a specific thing, I can model out a table schema or something that's going to help me answer that question. The data modeling happens after you decided what questions you want to ask. And so that creates a very time-consuming process. And so as businesses evolve and the BI organizations want to ask new questions and bigger questions, it becomes a big backlog because of the time and the effort it takes to do this. And this kind of cycle of, well, we'd like to ask a new question, now we have to go back and remodel it and find ways to load that data in this format into our applications. That creates this backlog that essentially creates a problem where the latest and greatest data that they want to look at is not accessible quickly, and it's not accessible right away, and that's probably the most important data that they want. And so this backlog really creates a lot of issues, which leads to the fourth and probably the worst problem with the legacy way is once you encounter these three issues, organizations start doing special things because they still have the same business pressures and the same deadlines. So what do? They go create special systems and special databases that'll help them answer these questions. But in order to do that, they have to just pull out and duplicate some of the data that they had before. They also don't have that full 360 view because the data's been reduced, and they create an unscalable architecture because now not only do they have their ETL data warehouse that has to be maintained and scaled, but it has to consider all these side silos of data that they've created in order to answer the question of yesterday and the day before that. So it basically creates a self-perpetuating problem, because in order to get around the first three challenges, they create another problem that worsens the first three challenges. Because if you can't scale your data, you can't load in more data, and it perpetuates itself. And this is why the legacy way is faltering, and it's not really keeping up, and Hadoop is becoming a well-known technology amongst enterprises today. And I'll explain a little bit why. So first, Hadoop helps address all four of these challenges. The first one is the dark data that I spoke about. So Cloudera calls EDH, it names it an enterprise data hub. What it essentially is it's one place where all of your data is stored. It is your single source of truth. It is your database. And we call it an active archive because you're bringing your applications to the EDH. And rather than trying to take your data, transform it, and bring it to the application, instead, you're loading the data into this one location, and then you make this data accessible to your applications by bringing the app to your enterprise data hub. And the good part about this is, one, it's economical because you're leveraging scalable and commodity hardware, but it also doesn't cause you to have to create an archive data, creating that dark data concept. And so you can continue to store data over time forever at an economical way. And you don't have to make those tough decisions about what data is relevant to you today, realizing that next year it actually was relevant. We talked a little bit about how you lose data in the transformation process. And that is also eliminated with an enterprise data hub. And the reason why is you don't have to transform this data to ingest it into the enterprise data hub. Because the enterprise data hub can take unstructured data. You can put data completely unstructured. Maybe it's a scrape of blogs across the world, or maybe it's a semi-structured format from sensors, or PDFs, or video, or audio. It doesn't matter. You can put and ingest this data into an enterprise data hub. And in some ways, we have technology that is allowing you to do it real time. So the data is literally growing as things happen in the world. And so in this process, because you don't have to do the transformations to get the data into your enterprise data hub, you're not losing data in that transformation process. So again, you're still sticking with one place that has all of your data. So with that, when business intelligence groups and organizations are trying to ask new questions and help grow their business by learning things about their customers or about their products, they're able to do what's called a concept of schema on read. But essentially what that means is schemas are being created as data is being ingested into the enterprise data hub. And so as data is being added to the enterprise data hub, business intelligence can be done and exploration can be performed in real time. So you don't have to wait on an ETL process to access the data that you wanted or needed in order to figure out how you can reprioritize your sales leads higher. You can explore that concept as new data is being added every single day. So there's no backlog in a sense, because there's no need to wait for a lengthy ETL process. You can access all of the data immediately. And that's a key concept, because what's happening is the business intelligence field is growing rapidly, and one of the reasons why is because we have the ability for us to answer these questions and to explore what other questions we might be able to ask immediately without having to wait on ETL. And with all of this, because there is a central enterprise data hub on scalable technology, you have a single consolidated architecture. You're not having to deal with that fourth problem of organizations creating their own silos of data because they didn't want to have to wait on the business intelligence groups or the backlog to catch up. So you don't end up with those special cases, and the architecture that Hadoop brings supports the backlog, and the goals of the business intelligence groups. And so those are the 4 ways that the Hadoop platform addresses the challenges that are brought on by the new and the big data that is a phenomenon today. Speaking of Hadoop, Apache Hadoop is what is the basis of the technology that supports this. So it's not just Cloudera. We have many competitors that also provide Hadoop. And Hadoop is a completely open platform. It's open source, and it's governed by open standards. About 80 to 90% of it is actually governed by the Apache Software Foundation. And Cloudera has over 100 contributors to the Apache Software Foundation group. And if you look over time, back in 2006, Doug Cutting created the core Hadoop. I don't know why that happens, but it'll do it again. Back in 2006, and it just consisted of batch processing and storage. It was very simple. There wasn't a lot to it. There was MapReduce, HDFS, and a core piece of technology that connected the two. But over the past 7 years, many, many technologies have been developed. You find technologies that allow you to do SQL on top of MapReduce. So essentially, applying what everyone knows as SQL to searching through PDFs and finding data across video files. And so that allows people who already know one technology like SQL to leverage that technology to find data in unstructured, find answers in unstructured data. You also have things like HBase, which is unstructured databases, or allows you to store the unstructured data. Flume and Kafka, which helps you ingest new data. Kafka is interesting because it actually is independent of Hadoop. It's a messaging system, but it's widely used within the ecosystem. You have things like Uzi, which is a workflow management tool, and you have Zookeeper, which is a scalable configuration utility, and many, many other things. Sentry, which is a security, Spark, which enables ingest, and lots of other technologies are being created by the community every single year and every single day, because this is being driven by multiple companies, and it's not just one company driving this technology. At Cloudera, we provide this technology, and it's powered by Apache Hadoop. So we essentially sell Apache Hadoop. There are around 28 components today that's part of our Cloudera Enterprise product. And so if you're a developer and you want to explore this technology, it's one thing to go download it and do a hello world and a readme and learn about it. But in an enterprise where you have a team of people or even multiple teams of people that need to leverage this, you really expect a different level of service. And so that's what Cloudera focuses on. We take those 28 plus components, we figure out which releases of each one of those open source components make sense to work together, and we test and certify them on various deployment patterns, such as in the cloud or in a private or public cloud, in a hybrid environment or on-premise. And our test teams and our development teams fix bugs along the way as we find them and contribute them back to the open source platform. That's also available, by the way, to our competitors. And because it's an open platform, the technology itself continues to advance, which you don't really see that in the old way. You see each vendor advancing their own technology. But we are in a different world here, and we're all working together to advance the technology that grows all of our businesses. One of the other things that Cloudera provides, though, on top of the open source, is extra security and administration. So through the purchase of a company called Gazang, we added security features to Hadoop, which was never part of the original architecture. We also built another tool called Cloudera Manager that enables you to easily install and deploy Hadoop in all of these 28 components, to also upgrade them and to possibly push data out to each of the nodes that is part of your deployment. So as part of our offering at Cloudera, we provide a certified version of all these components working together that's been tested. On top of that, we provide security and administration, but we mostly sell support and services and training that go around that. And so we also help teach you how to use it. And there are companies today that are, we have many, many customers that are leveraging this technology, and I'd like to just take you through about 4 use cases. The first one is Caesars Entertainment. So Caesars Entertainment is in essentially the gambling business, a big part of Las Vegas, but they also have many other parts of their business. And they were asking bigger questions, and they were wondering how can they grow their business outside of gambling? So how can they grow their retail? How can they grow their restaurant business? And they wanted to leverage the data that was available to them. So they had surveillance data that's part of their casinos. They had all of the transaction data that were part of their restaurants and their retail businesses. They also had a loyalty program where people signed up for their loyalty program and enabled them to give offers to their customers. They also had traffic data, publicly information, social data where they could understand the sentiments and what people thought of their restaurants or what people thought of their retail stores. And they decided that they could learn from this and they could gain from it. And what they did was, using a pilot of a Cloudera Enterprise, they took all of this data and they developed a very, very targeted marketing program where they noticed traffic patterns in Las Vegas, and not only in a car, but also people walking and being stuck inside of crowds, because Las Vegas can be very crowded sometimes. And they took their loyalty program application that people have on their mobile phone, and they give you offers. So they might give you a half off of an appetizer when they notice that you're stuck in traffic right next to a sushi restaurant that they happen to own. And so these are the kinds of things that Caesars has found very useful and has used this to grow their revenue outside of the gaming industry, diversify their business, and make them more robust as a company. And this is all using Cloudera Enterprise and big data, in a sense, all these sources of data we talked about. Another one is eHarmony. So eHarmony had a little bit of a different problem. They were already doing rather advanced analytics. They were using the old way, and they wanted to see if big data could help them, because what they were struggling with was the scalability problem. They had new customers signing up every single day for this matchmaking service, and they wanted to provide better and better service to stay ahead of their competition to each one of these new customers, which means finding more and more out about you as a person so they could make a better match for someone out there for you. And in order to do that, they found that they got stuck by those 4 challenges that I talked earlier about, the limitations of how much data they could store. As they grew their customer base, they became slower and slower and slower. And so they decided to adopt the Cloudera Enterprise software, and as a result, they're able to deliver 10 million matches to each one of their customers. Well, 10 million matches, they have about 10 million customers every single morning. And so what eHarmony does is now they're collecting more and more data about each person. They don't have any limits there, and they continue to provide the same level of service, and they can scale their service as they have more signups, which ultimately scales their business. So Cloudera Enterprise and Hadoop help them scale what they really had already been doing by using the legacy way. This is one of my favorites because it's not just being done by Mitsubishi Electric. It's actually being done by many, many companies and many customers of ours and also our competitors. Mitsubishi Electric, working with Intel, is manufacturing parts in all of their machines that have sensors. And these sensors report back diagnostic data. And they save all of this data all over time, which enables them to do a few things. The first one is they noticed that they had a high error rate when they ran tests to determine if parts were good or bad. So before they started using Hadoop, they would randomly run tests on parts to determine this, and there was a high error rate, and they wanted to fix that. So they started using these sensors to record diagnostic data, which enabled them to be more accurate with when these parts were going bad. But then they took it a step further, and they started analyzing patterns so they could actually predict when parts would go bad. And this helped them save even more money because what they can prevent is component failure. So they essentially prevent downtime in the machines that they produce by analyzing sensor data and predicting when a part's going to go bad and proactively going out and replacing that. And that's not just happening in Mitsubishi Electric, it's happening in the airline industry, in the oil industry. And that's why I really like this use case, because it's saving, environmental problems, it's saving, airplane crashes. We're using these technology to really be predictive about when the parts that we as humans build and could potentially falter in the future. And the last one that I'd like to cover today is Cerner. So Cerner is a healthcare company, and they have really just started adopting the Hadoop platform. And what they're doing is they're taking this and trying to provide prescriptive medicine. And they chose to first focus on sepsis, which is infection in the blood. And what they're doing is they have sensors that people can wear, and they can have real-time detection and analytics of their bloodstream. So people that might potentially encounter this problem can wear a device, and there are servers back at Cerner that are constantly monitoring them and determining whether they might be susceptible to sepsis in the future or in the near term. And this is helping save lives. But they're also doing other things though. They're analyzing the genetics of us as people. They're combining that with healthcare trends that they're seeing across all the hospitals in the world. And they're being more prescriptive about what medicines can be prescribed to people. And they're also being more accurate about whether someone can be released. They're helping communicate to doctors that they notice a problem that, this person follows a certain trend that tells them that they will be, readmitted to the hospital in a week, and possibly they should take further analysis and look at that. And so it's really helping the healthcare industry take big strides. And it's, what they're really developing is a complete picture of the patient, the condition, and the trends of that condition. And using all of that data together, they're improving healthcare. So that's all I had for my presentation today, but I want to leave you with one bigger question, because that's our motto at Cloudera, is to ask bigger questions. And this question is, how do we feed the world? Interesting question, because if you look at how much food needs to be produced to feed the world, in the next 30 years, we're going to have to produce the same amount of food that we've produced over the last 10,000 years combined. That's a lot of food, and we really have to optimize food production even to just stand a chance to keep up with where we are today. And there is a company, a customer of Cloudera, a Fortune 500 company that's working on this problem. And what they are doing is they're putting monitors in farms, and they're analyzing the soil content. They're analyzing the weather patterns. They're analyzing the wind. They're also taking pictures of the plants, sending the photographs back to their enterprise data hub and analyzing color changes. And all of this data, the humidity, anything you can imagine, they're capturing. And what they're doing is they're working with the farmers to figure out which seeds grow best in that geography. And their goal as a company is enormous. They're not trying to figure out just which seed grows best for a farmer in Iowa. They're actually trying to figure out which seed grows best for all farms across the entire world. That's the goal that they have. And so they really want to really understand, what grows best in Ukraine and what grows best in California. And they're using all of this data to understand that. And, while this is a big question, they are at least making big strides to try to solve that question. So that's all I have today. Does anyone have any questions for me?
I've actually got two questions. So the first one is, what are the most important open problems left in big data? Is it about making machinery more cheaper, or is it about creating new paradigms to replace MapReduce or something? So.
So what's the most
important open problems left in data?
Oh, the open problems. I'd say that having a mature platform, it's still very early, and the the biggest problem of Hadoop today is that the community, the open source community, is advancing it so quickly that it's very difficult to keep up. And as we all know, software needs a certain level of maturity before certain enterprises can take on that technology, and that's kind of it's in kind of the teenage spot of the technology.
Sure. And the second question, what do you think of, I guess, new frameworks in the Hadoop ecosystem, such as Spark, which was originally just a replacement for Hadoop MapReduce, and now it has machine learning, it has batch processing and stuff. Yeah, what do you think of that?
Well, we just introduced an initiative to add Spark as an official part of the Hadoop platform. So we definitely want to embrace Spark, and we believe it is definitely one of the better ways to do things today.
I have one more question related to the Hadoop. So all of the cases that you showed us here, so they deal somehow with the predictive analytics, right? So with the machine learning, etc. And as far as I know, so Hadoop itself doesn't have any algorithm implemented. So it has machine MLD based on top of the Spark. It has Apache Bibighaus. And so what were other components with the Hadoop probably to build this solution? The predictive analytics.
What are the other
what are the components? Yeah, because Hadoop itself is just data engineering and data management, right?
Right, yeah, it's the infrastructure. So you still have to develop the algorithms, you still have to hire PhD students and things like that can really figure out how to do the analysis.
So basically it was useful to speed up the data processing, right? Or the huge data processing.
Correct, it adds scalability so you can have more data, right? And then it adds performance optimization, essentially, and it makes it more easy for exploration to be done on the data, but you still have to do the analytics. And there's companies that are specializing in that.
And one more question. So, what is wrong with the Hadoop right now? Because at the beginning, so when it was developed, so there was one killer feature, so one key feature that it should be run on commodity hardware, right? But last time when I read the recommended specification for hardware, so even on the Cloudera website, so it says your servers need 46 gig of RAMs and 8 core processors with a high-speed SSD hard drive. But it's really not a commodity hardware, right? It definitely can set up and install the Oracle on that hardware and other corporate products for even for SQL code.
Yeah, I mean,
well, what is
it's a great question, yeah. I mean, it definitely, from our perspective, doesn't require the same kind of hardware if you were to do the exact same kind of data processing in an Oracle. And I think that's where, the answer is you can run Hadoop on smaller hardware, but as you grow your data, it does require more processing power. But you can also scale in other ways by adding additional nodes. So it gives you a little bit more flexibility in that sense.
The final question is whether it's still cheaper or not.
It is definitely cheaper, yeah. I mean, especially when you factor in, the storage devices, that's very expensive in the old way. Any other questions?
So what is the future of Hadoop? Because as it was already mentioned, the Spark is chasing the Hadoop, right? So because memories become cheaper, and at least you can put the hot data into the memory. So what is the future of Hadoop and Spark? So how do you
the community trying to embrace one platform. I think both Cloudera and our competition is wanting to do that. We're doing it in different ways, but we want a mature platform that's still open.
So basically, it was we can have two options: Hadoop or Spark, right? So
at the moment, it's kind of like that. But what both companies are trying to do is advance the platform itself, and it's going to end up converging at some point. And you see companies like Hortonworks having their open data initiative. We also support that, but we're doing it in a slightly different way. But it's not just Spark in a sense. If you look at things like Impala and various other technologies. You have Embari for Hortonworks that kind of competes with Cloudera Manager on our end. You see amongst this ecosystem a lot of competing products or competing components. And right now it's very difficult for someone to really understand which one is best for their business, right? And for us, what we do is help companies make that decision. So we're not necessarily reliant on Spark or Hadoop to be successful as a company. What we help companies do is really understand what's best for their business, and we help train them and support them as they use this technology. And so while you might have developers liking one technology over other, or one is jumping ahead of the other, we view it as one big picture, and they're ultimately going to converge into a mature platform. But we see it as far, far from mature right now.
Does it compete with the Oracle in the enterprise domain?
Do we compete with them?
Compete with them, yeah, because in the banking, let's say.
Yeah, that's probably our #1 business driver, is going in and essentially ripping out Oracle from businesses. So we go in, we convince them to do away with their ETL, to do away with their processes, and we try to complement that at the beginning. But essentially, we convince them that Hadoop is going to be the way of the future for them. And that's where the majority of our business comes from. So.
Okay, thank you.
Thank you.
For your